Hello and welcome to this tutorial on how to make some procedural floating atmospheric particles. Dust motes, I think they're called. As you can see here, we've got some interesting variation in shapes. Also their movements are varied, and also we've added a bit of rotation as well. Let's jump right into it. So starting off with my empty scene, I'm just going to drop down a geo container, call it dust. And we're going to dive inside. So first thing we're going to do is drop down a box. It's going to be our container. We're then going to use a node called points from volume. We're just giving us some points inside the box. We're just going to increase the jitter scale so it's nice and random. I'm going to visualize points. For now, we're going to keep the point separation to the default, and then we can decrease that later to get some more points. Next, we are going to add some geometry to scatter to these points. So the first dust shape I'm going to create, and you can use your own, but for now I'm going to show you what I used. First one I used was a sphere, which I then set to polygon, just increase its frequency. And I also used a mountain, very popular node. It's useful for a lot of things. Just quickly give us some variation. And maybe the sphere, I'll decrease the radius in one axis, just so occasionally if it's rotating we'll get some slightly narrower shapes. Just a bit more interest really. Next I'm going to drop down a box. And same thing, adding a mountain to it, and then just making sure that we have enough axis divisions so that this mountain can really start pushing and pulling the shapes. I'll decrease the height of the mountain a little bit, maybe decrease the element size, something like that. Maybe I'll make it a bit thinner on one side. Whatever you like really. I'm going to use one more, and for that I'm going to drop down a line. This is going to be more like kind of hairs, tiny hairs floating around. First thing we're going to do is just increase the amount of points, and then we're going to use a point jitter. Lots of different ways you can add noise to this line. I'm just going to use a point jitter quickly. And just decrease the scale. Next, I'm going to drop down a polywire. Just going to flesh out our line. And we're just going to give it some more divisions and decrease the wire radius. Maybe even give the line a bit more length, twice the length. Something like that will do for now. Next, we are going to use a merge to bring all of these together. So I'm going to select all of them, and then if I hold Alt, I can merge them all together by letting go, clicking and dragging and then letting go. Next, we're going to drop down a connectivity node. And by default, the name of the attribute is class. We actually want it to be name. See here, they've now got name. And then that means we can use the attribute from pieces node here by giving the points into the first input. See, it's looking for point cloud, and then this is the geometry library, which is essentially what we've created here. So that's looking for that name attribute, and it's assigning based on the amount of connections that we have, 0, 1, and 2. It's assigning a random integer to that attribute name, which you can see here, which means that if we use a copy to points, so the points go into the second input and the geometry to copy goes into the first, make sure we have pack an instance enabled, and then the target points we leave, but the piece attribute we can change from variant to name, which is that same attribute that we've set here. So now if we view our copy to points, it's randomly assigned geometry to each point. At the moment though, there is no p-scale attribute coming in, which means that they're all defaulting to their original sizes, which is too large at the moment. So if we drop down attribute randomize, we can name this p-scale. Then instead of CD, which it's currently assigning randomly, we want to assign p-scale. And this is just a float, so it's one-dimensional. And then at the moment, we probably only want to vary between 0.5 and 1, and then we can use this global scale just to bring it down, something really small. As you can see there. At the moment, I'd say my tiny pieces of hair are probably too small in comparison to our slightly larger shapes. So I'm just going to drop down and transform here. And then I'm going to use the uniform scale to just bring up the size of this line. The next thing we're going to do is add some random orientation. So to do that, we're going to use an attribute randomize again. And this time we're going to set it to n, which as you can see has randomly offset the starting position. If we hit -1 in these, it will just add a wider range that it's randomizing between. So that's our random starting positions. The next thing to do would be to add some movement. So to do that, we're going to be using an attribute VOT, which we can call animate. And I'm just going to color it using C. I can pop open this little color grid, and I'm just going to color it something nice and bright so I can find it easily. And if we dive inside, we're just going to use some noise to add some movement. So I'm just going to go with the top one, flow noise. And I'm going to pipe in P into position. Then I'm going to use an add, which is going to add this noise back into the original position. So at the moment, the default is 1D noise. We want 3D noise. Pipe that into the second input of the add, and then into the P. So if I move this offset, you can see what it's doing. So we're just going to play with a few of these settings. First would probably be to increase the frequency. And then to make this animate over time, we're going to be using this time attribute, which we can pipe into the amplitude. If we hit this for real-time toggle, hit play, you can see it's moving them. At the moment, it's probably too fast, so to give us some control, we're going to be using multiply constant. And I'm just going to set this to something a lot smaller. If I hit play, you can see it's moving a lot slower now. So the next thing I want to do is add a bit of variation in their speeds, just to make it a bit more interesting. So I'm going to use the random node, which is going to take in the point number, give us a random output of 0 to 1, which we can then fit and control in here. So this is essentially the min speed, mult speed, and this is the max. So if I use another multiply here, at the moment, if I press play, you can see that it's varying between 0. Some of them are not moving at all, or barely. And others are moving at 1. So I just want to bring up that min value to something like 2, just so there's always a bit of movement. Next, we're just going to add a tiny bit of spin so that they're not just statically flowing throughout the scene. So to do that, we're going to be using a wrangle, which you can drop here. And this one we can call orient. So what we're going to do is we're going to initialize a float attribute called angle. And then we are going to set angle to @frame, which is the current frame number that we're on, because obviously we want this to change throughout time. And we'll leave it at that for now. And then we're going to set an intrinsic attribute called orient, which this copy to points knows to look for. So @orient equals, we're going to use a function called quaternion. So the first input is going to be our angle, and our second is going to be that normal attribute that we set earlier. Then just below it, we're also going to initialize another intrinsic attribute that the copy to points is looking for, called up. And up we're just going to set to our normal attribute as well. As you can see, that's immediately done something. Hit play. It's already doing some random spinning. However, we want to vary up the speeds and also control the max amount of speed that we're going to get. So the first thing we're going to do is initialize a custom channel float that we're going to call molt. And then if we hit this, it gives us this parameter. So we're going to set that to something small. So now they're spinning a lot slower. We also want to add some variation to the speeds. So to do that, we're going to multiply our angle by a fit01 function, which is going to take in the random output of our point number, very similar to almost exactly the same way that we varied the speeds inside the VOPs, but this is how we do it with effects. And that's using the point number as a seed. And then we're going to set the min to be a custom channel float that we're going to call min. And then the max to be custom channel float that we're going to call max. Just give it 2 brackets at the end and hit this. Max is going to be 1, min is going to be 0.1. And if we hit play, you can see that we're spinning at random speeds. As you've probably noticed, our strings, our tiny hairs, are currently spinning around a funny pivot point. We want it to be spinning using its center mass of gravity. So to do that, if we visualize our line, you'll notice it's growing out from the center. We want to centerize it. So if we just take our length and paste relative references in our y of our origin, we can then minus that and times it by 0.5, which makes this procedural now, so it's always centered, which is handy. So now if we were to visualize our final output, you'll see that the strings are now spinning around their center of gravity. All right, we're getting very close now. Our first frame, they're currently all pointing upwards, so to fix that, we're just going to add an offset to our angle. So right at the end of all of our vex stuff, we're just going to add a number, something large, like 200 will do. And that's just going to offset it so that we start off slightly more interesting beginning orientation. All right, now you have all the controls you need to keep tweaking this, and you can keep adding some more shapes if you want to scatter randomly. This should all update procedurally. I'm just going to quickly set this up for rendering to show you how that would look. So I'm just going to call this node out dust, just dropping a null. And we're going to want some correct motion blur. So we're going to need to calculate our velocity. So we can use a trail node for that, which we can set to compute velocity. That's now giving us some velocity, some v, which is essential for rendering. Then if we go out, we can just drop down another geo container. Call this ren dust. I like to color them pink. We're going to use an object merge to look for this dust container, and then inside that null that we've named out dust. And that means that no matter what, we're always going to be rendering the part of the network that we want to render. Next, we're probably going to want a camera. So I'm just going to drop down a new camera and hit the padlock and just position that somewhere I like. Something like that. And you probably noticed that my dust is probably way too big still. So in my P scale, I'm just going to bring that down. We're then going to want to assign a material to our dust. So if we go over to our material context, we'll just drop down the principled shader. Call this dust. Probably set base color to something a bit brighter. And the roughness, we probably want something a bit high. And the reflectivity, something about 0.5, but you can play around with this. And on my Ren dust, I'm then going to set that to our dust material. Then in our out context, can then drop down a mantra node. And just to give you a heads up on a few settings I found useful, first being obviously using physically based rendering, and then you just need to make sure that your pixel samples are quite high, otherwise you might get flickering. Something like that. Then my limits always set something small, don't really need much. And color limit can also be brought down. Then the next two things would be allow motion blur. And then either you can render with the depth of field enabled, or in your images tab, you can add the extra image plane shading depth, which is probably the much more common practice in a production workflow. However, if you don't have any post-processing software that can use a depth pass, then I would recommend using enable depth of field, which you can control using your camera. If we visualize our handles, we can then right click and use our focus handle, which at the moment is set a bit too far away. So you want to move this box to the center of where you want to focus, and then this just changes how much blurring you get away from that center. Something like that. We can then turn on depth of field here by right clicking on one of these light bulbs. So at the moment you can see it's really shallow. But this is not 100% accurate, so it's much better to do a formal render. Before we do that though, we obviously need a light. So I'm just going to drop down an environment light. And then by default, you get some environment maps for free with Houdini, which you can find $HFS, which you can probably see as one of your bookmarks. And I'm just going to use this HDRI Haven Lennon map. You can also go to HDRI Haven website and download other free maps. Now that I have that, I can then go over to render. And after testing this out, you may not have any issues with flickering if you use high enough samples, but if you're still getting persistent flickering, then there's a few tips I can show you. One of them being if we go to our mantra node and hit edit render parameters, then in our create parameters we can look for a parameter called jitter in our sampling, which if we hit this arrow we can then add to our mantra node. We hit apply and accept. Then we can see this jitter is currently set to 1. If we turn that to 0, that may help your issues of flickering. I hope you found this tutorial useful. Thank you for watching.